Hello, take a look at this nifty little trick. Hey Arduino, what's the time? How should I know? You're smart, aren't you? Leave me alone. Oh, almost forgot my lines there. Leave me alone. Hey Arduino, how should I know? What's the time? You're smart, aren't you? You're smart, aren't you? You're smart, aren't you? You're smart, aren't you? Hey Arduino, what's the time? What's the time? Hey Arduino. So that's pretty neat, isn't it? So the way that that's working is by this module here, which I bought on Banggood, and I have to admit I have absolutely no purpose to be buying this, but as with a lot of things, I just sort of buy them because they look like fun and they don't cost too much. This one was a little bit pricey as far as these things go, $21, and that's the page there. So I've just been playing around with it and I got it to work, so I thought I might show how it works. There's actually a few videos on YouTube already. I'll put a link in the description to a video that I saw where he demonstrates the possibilities for what you can do with this a little bit better. But the possibilities for what you can do basically just rest on how much effort you want to put into writing the program to deal with different states. So this is called, what is it called? Geeetech voice recognition module with microphone, voice board for Arduino, and it comes with the board and this bendy microphone stick thingy, and it also came with some of these female to female DuPont wire connectors, which I've just swapped for some colored ones because they're a little bit easier to use with colors on. So that's all you get in the kit, and that's all you need really. And we can see on there it has a UART. Oh, some of those turned on. There's a UART connection on there, just the ground, RX, TX and VCC on the left, and it looks like what is probably an auxiliary connection for the microphone on the right hand side where it says ground and VOC. So if you didn't want to use this microphone, you could connect your own one up there. And then there's a couple of big caps and a whatever that thing is, and then there's another one of those over there, and there's an LED flashing up the top and some pins. I haven't really looked into this stuff in too much detail, and a few little bits of SMD thingies on the bottom. So I thought I'd make a video just to look at how you set this up, because it's not difficult, but it's a little bit unusual because you have to load all of the sounds to be recognized onto here before you start to use it. And you do that, at first I thought you could do it with the Arduino serial monitor, but it turns out you kind of can't, because you have to send a specific hexadecimal byte to the board in order to start it into the mode where it learns what you're trying to say. So I have a couple more pages here to look at. This one I'll put the link in the description as well. This is just sort of an overview of how it works, and we have a little bit of source code down here which you can use, but this code here you would use after you've already loaded the voice samples into the board to use. So this FTDI adapter does not come with the set that you get on Banggood. Oh, it doesn't actually list up what you can do here, but so as you saw in the beginning there, I was using 5 separate commands, and that's all that you can do at the same time. How should I know? Oh, oops. How should I know? You're smart, aren't you? You're smart, aren't you? Well, that one's a tricky one, isn't it? You're smart, aren't you? All right. So you can only have 5 samples loaded to detect at a time, but you can have 15 samples total. So you could perhaps use one of your voice commands to switch to another set of 5 samples to listen for. I'm not sure how long it takes to switch, but I imagine it will be pretty quick. So let's have a look at one of these other pages, and this is the one where you find all of the actually useful information. This is the actual user's manual, and it's got a few more specs there, but it basically jumps straight into the protocol that you can use to set it up. So the way you do it is you have to send over the UART connection, you have to send, that's 0xAA, so that's the hexadecimal byte AA, and then key, which will be one of these. So for example, 0xAA, 0x00 would enter into the waiting state. And then for each of our 3 groups of instructions, we can delete the instructions. So that's 01, 02, 03. Oh, we can delete all of them like that. And then 11 will begin to record the instructions for group 1. 12 will record for group 2. 13 will record for group 3. And then to load them up to start using them, to start trying to detect them, we'd use the 2 set of commands. So it'd be 21, 22, 23. So this is all a bit sort of weird, but as we do it, you'll see it's not actually that difficult. So I've already set up the first set of commands, so I think I'll just leave my 1 suffix stuff as they are, and I'll set up a second bank of voice commands to detect, because I want to point out a few things that you will probably trip up on, as I did when you first start using this. So the problem with the Arduino serial monitor is that you can't send a byte like that very easily. You can only send ASCII text. So the way I did this was I am using a serial terminal utility called HTerm, and this is quite conveniently available for Linux and Windows. I haven't tried the Windows one, but I presume it works just the same as the Linux one does. So let's use that. First I have to set up my connections so that the Arduino, we're going to have to take this out of the loop completely. And so we just have this module, and I'm going to connect that to my FTDI adapter in the normal way that you do. So that's ground and VCC, and then RX goes to TX and TX goes to RX. So TX is blue is going to RX, purple, blue, like that. So that should be this ready to go. And I've got to plug it in. Hold on a second. So that's the only connections you need. And we can see that it starts up and it's flashing at us. The manual says that this is supposed to change flashing periods in all kinds of different ways, but I've only noticed it to do it in one way, and that is when it's waiting, or when you've finished loading the samples. Okay, so the HTerm program is started up here. You can see a little bit of stuff that I've been doing already, and I'm just going to connect to this, and it should be, if you use your Arduino ID, it'll be whatever you have in here. There should be a serial port available in the same name showing up in here in this drop down box. So you would set it to 9600 baud and leave everything else the same and click connect. And I'm not sure if that worked. Did it work? Might have worked. Alright, and then to make sure that we're sending hexadecimal bytes to the device, we need to click on the hex checkbox down here, and then I'm sending AA21. That's probably not what I want. Let me just check what I do want. Right, let's just send 00 to see if we can enter into the waiting state and see if we get any response from it, because I'm not entirely sure that it has connected properly. So I'll go AA00, send. Oops, and it pops up over here. Okay, so another thing I should mention at this point, there are two modes. You'll see that there's two columns over here. One is respond in common mode, respond in compact mode. Now at the moment we are in compact mode, so all of the responses are just going to be single byte hexadecimal responses like this, 0x41. And when we're in common mode, they'll be more easily understandable text strings like this. When you're communicating with the voice recognition module from your Arduino, it's much easier to have a single byte to tell you what's going on rather than have to pass these text strings. So at the moment the module has been set into this compact mode, and that's why when we looked at this response here, it's just giving us some unrecognizable funny characters. So what I want to do is return it back to this common mode, and if I go right down the bottom of this table, you'll see a couple of commands that we can give it to switch to common mode, and that is 36. So remember we need to put an AA at the beginning of all the commands we give it. So it's AA36. Send and send. And I've found that I need to do this twice sometimes. Come on. 3 times. I don't know why it doesn't get it properly the first time. Quite often you need twice or 2 or 3 times to get it to work. So anyway, now we see common mode, and if I try my 00 again, now we should get something that we can actually read. So it says waiting, and then there's a carriage return and a new line after it. So that, oops, is this command here, 00, and it says respond in common mode. We get the text string waiting. So that means it's successful. All right, now I want to load in some samples to recognize, and I don't want to touch my first bank of instructions that I have already, so I'm going to do this. I'm going to do begin to record instructions of group 2. So that's 1, 2. Where is it? Here. So this is going to be 1, 2. Now I'll just wait a second before I send that, because as soon as you send that, things start happening pretty quickly. You have to be prepared to speak the commands that you want it to record. So I'll just scroll down to the bottom of this table. There's some there's an example of a recording session down here, I think, if we go all the way down. So you'll see it saying things like this: start, and then again, and then different, and so on. So it should be pretty clear as we go through. I'll try and make it fail a couple of times so you can see how it fails. But one point that I got confused about is, see how you get a list of strings like this? You get start, again, start, finish one, start, again, start. So it's a little bit sort of confusing, but this again one does not mean speak now. The only time you should speak is after you see start show up. Yeah, so that's the first point to be aware of. So let's go back here, and I will send this command, and we'll start doing some recording. Hello. Hello. So that was okay. Nice day. What'd you say? So those two were different, so it's telling you that that didn't work. So I think you just have to complete this process and until you get 5 samples that you said the same thing twice for. So I'll just finish them off with I'll just say some numbers because that will illustrate something else I wanted to show you as well. 2, 2, 3, 3, 4, 4, 5, 5. Okay, so yeah, so again, you don't talk when it says again. You wait until it says start. And another point that I discovered was that when the first few times I tried it, I tried to start saying my sample immediately as it says the start popped up to try and because there's a 1.3 second span of time that it records for. I think I saw that somewhere. Where does it say that? Oh, somewhere in here it says there's a 1.3 second long time for the sample. Oh, never mind. So I thought I need to start speaking as soon as the start pops up to record the longest sample. But it seems like there is a little delay after the start shows up, that it's a good idea to wait just a fraction of a second after it shows up and make sure that you have you have some empty sound, like some silence at the beginning, and also preferably a little bit of silence at the end. Really, really helps for the recognition when you're doing it, when it comes to detecting the commands. Anyway, so that's done group 2. Another thing that's a little bit confusing is it says finish 1, finish 1. I would have made it say finish 1, finish 2, finish 3, finish 4, or something like that. Anyway, but that when you see this here, you have successfully recorded your 5 samples. Now, I think at this point it'll just do nothing. So if we want it to start detecting those, we have to load in or start to be ready for voice instruction here. And if I want to try my group 2, I need to give it a 2-2 like that. So let's do that. 2-2. Go. Now it says group 2 imported, and I can try them out. So 2, 3, 4, 5. I was going to say 6 then. What was the first? Hello. Hello. 2, 5, 4, 3. Okay, so you can see that it's detecting those quite well. This brings me to the next thing that I wanted to show, and that is that if you have a quite a short sample, especially a one-syllable word like these numbers that I've just recorded, they tend to get easily detected when you are saying things that are not actually that sample. So let's see if we can do it here. Tree, live, strive, door, moo. So those vowels that I said there are the same vowels, or those words rhyme with the numbers. So it's detecting some inputs that I'm not actually trying to give it. So to avoid that, you have to really make your voice samples maybe 3 or 4 syllables if you can, and make them a little bit longer. So try and fill out the whole 1.3 seconds of time that you have, and give each of your commands as much texture as you can to be recognized. So single syllable words like 1, 2, 3 are not very good. All right, so what we are being given here on our serial monitor is some text, which is nice to confirm what we are, confirm that we've recorded everything properly. But when it comes to interacting with this from our Arduino, it's kind of a pain in the ass to have to look at this and detect RESULT, comma, colon, and then pass this text string in. So that's where we would like to switch into the compact mode. I think it was called, what was it called? Compact mode, yeah. So to switch into compact mode, that's this one here, and that is 3.7. And I'll just turn hexadecimal displays on here as well, so you can see the light blue is the ASCII, and then the darker blue below that is the hexadecimal equivalent. Now I've forgotten what number that was, 3.7. So switching to compact mode, 3.7. Try it again. Try it again. Try it again. All right, one more tip. If it just doesn't seem to be doing anything, try doing 0, 0 to go into the like idle state, because that always seems to work. Yeah. Okay, so waiting. And now we'll try 3.7 after that. All right, now it says compact mode. So now if I say one of my samples, 1. Oh, no, I didn't record that, did I? Hello. Oh, all right, so we're in waiting mode. So sorry, there's a, is this getting any clearer, or am I just sort of muddying the waters? So because I went into, because I did this just now, we're in the waiting state where it's not going to do anything. So I have to come back here and import my group 2 to be ready for voice instruction. So that's 2.2. 2.2. Right, now this CC here is just the response that means it's successful there. But we can see that we are now being given just single bytes. Hello. 1. Oh, 2. 3. Door. 5. Live. Hive. Jive. Strive. All of those rhyming words are being detected as 5. So the point is though that now we're just getting single bytes, and this is a lot easier to deal with from our Arduino, which is the next step. So to finish this off, let's just have a look at the sketch. Well, we'll look at the sketch that I wrote, which is this one, but I will just remind you that it is available on this page as an example down here. So I looked at this and then I wrote my own, so it's a little bit different, or I copied this bit here. So let's just look at what I had running at the beginning of this video. I have an array of 5 booleans, and that just stores which LED is currently on. Pretty simple. When we start up, we begin a serial connection at that baud rate, and that is the connection to the voice module. And then I do a little bit of housekeeping here to set every member of that array to be false, and then we set pin modes to be output for those pins, and then we turn all of the LEDs off. And I'm just putting this in a loop because it just keeps things a little bit more compact. And as for the pins, I'm using 0 plus 2 will be 2. And then the next iteration I will be 1, so this will be 3. And as you can see, the pins that I've connected stuff up to just for this little demo are pins 2, 3, 4, 5, and 6, like that. So that's why that loop is like that. And then we wait 2 seconds, which I guess we need to do for the voice recognition module to start up. And this is the piece that I copied verbatim from this example. So then we send AA37, which, as we just saw in our datasheet, we'll do this, switch to compact mode. So this just makes sure that it's going to be in compact mode when the Arduino tries to use it. Wait another second, and then we load in this case we've loaded in 2.1 is the set of the first set of instructions, group 1. So that's that there. And then we just go into this loop, and all we do in the loop is check if there is a byte available on the serial connection. If there is, we read it in, and if it's one of the bytes that we saw being given to us when we had some speech detected, like this, so 2, 3, 4. So these are the bytes that we're going to be given. So they should be in the range of hexadecimal 11 to 15. And we can subtract 11 from that to make this number, which this will then be a number between, well, from 0 to 4 that we can use to look up which of the LEDs we are talking about in the array. And then we just turn it off if it was on and turn it on if it was off, and then write that output to the digital pin, and that's it. So this is about the most basic thing you could do with it, just turning some LEDs off and on. But what you could do is use some more structure. So you could have samples like, you'd need one sample to make it wake up and listen to you, like Hey Arduino or OK Google or something like that. That is something that you're probably not going to be saying too often. And once you've done that, then you could go into another mode where you're listening for other sets of sound. And I'll point you to the link in the description where the other guy has done a pretty good job of demonstrating this in his video. So you could have things like, Hey Arduino, TV on, or TV off, or air conditioner on, air conditioner off. And that's quite useful because you've reused the on and the off samples to get more than 5 separate behaviors. But I think you probably know what I mean there. So anyway, that I think is about all I had to say about this. I don't know if I'm ever going to use this, to be honest. You never know, though. I have bought things in the past thinking I would never use them, and I ended up using them for something. So maybe this will be one of those things. But anyway, I hope that was a little bit interesting. And thanks for watching. See you next time.